Hello, my name is Jessica Tobler, and my project is atmospheric deposition at Utah Lake. Atmospheric deposition is the process by which particulates and gases, such as nitrogen and phosphorus, are deposited in vehicles such as rain, snow, and dust onto the Earth's surface, or in this case, Utah Lake. The purpose of my study was to investigate how much nitrogen and phosphorus was deposited into the lake for the year 2020. In conjunction with Dr. Wood-Miller and graduate student Seth Barris of Brigham Young University, and with guidance from Dr. LeVer Merritt, I observed the atmospheric deposition sampling process at Utah Lake, and also observed the laboratory processes for measuring phosphorus at Chemtech Ford Laboratories. For the past several years, there has been an increased awareness of naturally heavy algae blooms in Utah Lake. Researchers are investigating the role of nitrogen and phosphorus in Utah Lake in an attempt to determine the amount of interference needed. Currently, it has been shown that about 80% of the phosphorus and nitrogen added to the lake is coming from wastewater treatment plants. However, it was not until recently that another source was considered, the atmosphere. Understanding how much phosphorus and nitrogen are being deposited into the water will help us further learn about the lake's ecology, including whether or not the reduction of nutrients might help in mediating algae blooms. My goal for this study was to learn more about Utah Lake and its issues. I studied atmospheric deposition specifically because of its relevance and timeliness. This is a fairly new area of consideration, so doing a study on this topic would add new insight into Utah Lake and its issues. My goals for research were to learn about the history and known problems of Utah Lake and its current state. My goals for the field were to work with established researchers to learn the sampling and measurement processes, and to learn about the amount of phosphorus and nitrogen being deposited into the lake. My hypothesis was that there would be a total of about 5 milligrams of phosphorus and 14 milligrams of nitrogen. These values are based on the 2019 data provided by Dr. Miller and Mr. Barris. Samples were collected at the Orem Wastewater Treatment Plant in Orem, Utah. The sampling station is located approximately 1,000 meters from the shoreline of Utah Lake. 2 types of samples were collected, dry and wet. Dry atmospheric deposition is the dry matter depositing directly onto the surface of the body of water, such as dust. Wet atmospheric deposition is the nutrients carried by precipitation onto the surface, such as rain and snow. The sampling station consists of 2 buckets on an elevated platform. A smaller platform is connected to a sensor that moves to cover one or the other of the buckets depending on the weather conditions. When the sensor does not detect precipitation, it covers the wet bucket while allowing the air to interact with the standing water in the dry bucket. When precipitation is sensed, the platform moves to cover the dry bucket and any precipitation is collected into the wet bucket. For this study, these 2 sources were combined to give the total deposition amounts. Sampling stations are used at various locations around the lake because sampling across the lake itself would be impossible. Samples are then sent to Chemtech Ford Laboratories in Sandy, Utah to undergo testing. As a note, during phosphorus analysis, samples are digested using ammonium persulfate and persulfate digestion solution to convert them into orthophosphorus, which can then be measured using spectroscopy. Phosphorus for the year 2020 had a maximum value of 2.50 milligrams per liter and a minimum value of 0.04 milligrams per liter. The average per month for months January through February and October through December was 0.78 milligrams per liter. March through September was 0.25 milligrams per liter. The total amount of phosphorus for the year was 4.90 milligrams per liter. Nitrogen for the year 2020 had a maximum value of 5.1 milligrams per liter and a minimum value of 0.4 milligrams per liter. The average value for months January through February and October through December was 2.24 milligrams per liter, and March through September was 1.58 milligrams per liter. The total nitrogen for the year was 17.5 milligrams per liter. The results of this study show that more nutrients are deposited into the water via atmospheric deposition during the winter months, which are January, February, and October through December. This is due to increased precipitation and wind, which blows particulates into the lake during the winter months. These results are not the same as predicted, but they are fairly close. There is also not enough data currently to determine whether these results are abnormal. While a few milligrams per liter may seem insignificant compared to the hundreds of tons of phosphorus and nitrogen entering the lake each year from other sources, when the milligrams per liter are converted to tons for the entire volume of the lake, about 870,000 acres, an estimated 6.01 tons of phosphorus and 21.47 tons of nitrogen were deposited into the lake during the year 2020. When combined with the results from more sampling locations around the lake and across a greater time span, these estimates will better reflect the true amount of phosphorus and nitrogen being deposited into the lake. Utah Lake and its problems have been debated for many years. As more information becomes available, citizens and regulators can work to make the best decisions for protecting and using the lake. Continuing studies on atmospheric deposition at Utah Lake will provide more information about the nutrient levels in the lake and how best to respond to them.